Hi, I'm Professor Hall, and this is Medical Microbiology 2420, and we're going to be talking about the Antimicrobial Susceptibility Lab, or also known as the Kirby-Bauer Lab. You can find it on page 268 of your lab manual, and so if you open it up, that might be a good thing to do while we're doing this video. So, what this lab is all about is basically to test certain antibiotics against certain bacteria, and so we want to see the results of those antibiotics on those bacteria. You're going to be working in your groups of 4, so in your little color group, and then one group at your table will be the E. coli group, and then one group at the other end is going to be the Staph aureus group. So we're working with 2 bacteria, one bacteria for one group, the other bacteria for the other group. Okay. The supplies you'll need for this particular lab: we need 2 Mueller-Hinton plates, 2 sterile swabs, saline cultures of E. coli and Staph aureus, and then we're going to be using antibiotic discs, and these are little paper discs that are soaked in antibiotic. And the antibiotics we'll be using are chloramphenicol, ciprofloxacin, trimethoprim, and penicillin. You can find these listed in your lab manual throughout this lab, and so you can go ahead and look in your lab manual for those antibiotics as well. The Mueller-Hinton media is something that we haven't used before. We've used a lot of Nutrien agar, and it looks a lot like Nutrien agar. In fact, you can't really tell the difference, except it does have some different nutrients in it, and it has some very particular characteristics that make it useful for this type of lab. One of the characteristics is that the consistency of the agar is thinner and more even. So in other words, I kind of compare it to smooth mashed potatoes and lumpy mashed potatoes. This would be very smooth, very even, no lumps in it, so that when we diffuse chemicals onto this media, it diffuses very evenly and very smoothly throughout the media. So that's one thing. It also has a standardized pH, anywhere from about 7.2 to 7.4. So we have a very specific standardized neutral pH. Lastly, it should be poured to a specific depth of 4 millimeters. So our plates should be fairly consistent from one plate to the other, which makes sense in the idea of doing comparison testing. We want to make sure that our plates are standardized. The depth is important because if we pour them deeper than 4 millimeters, say 5 or 6 millimeters, then our zone of inhibition would be smaller, the diffusion of the chemical would be smaller. Or if we poured them thinner, then the diffusion of our chemical would go much further, so our zone of inhibition would be much larger. So it's important that it's standardized to 4 millimeters. Okay, so we also have a new streaking technique that we're going to be talking about. Lawn of bacterial growth. You've done streaking for isolation, dip and swish, and that kind of thing. This is a new one. So lawn of bacterial growth, basically what we're doing is we're taking a swab and we're going to dip it into our bacterial solution. We then want to streak our plate from edge to edge very, very evenly and very close together. So we want to cover the entire plate and have a nice lawn of growth at the end of the growing stage. Once you streak in one direction, turn your plate a third, streak it again, and then turn it again one more third and streak it for a third time. And I'll show you in just a minute how to do that. So lawn of bacterial growth. Lastly, once you get done with the setup of the lab, the next time you meet in lab again, you'll be reading the results. And how you read the results, you're going to be using the metric side of a ruler to measure the zone of inhibition. You're going to measure the diameter of the zone of inhibition. So from one end to the other end of the zone of inhibition, and you're going to measure it in millimeters. Once you get that measurement, you want to compare it to the measurement chart, table 7.4 zone diameter interpretive chart that's on page 271 of your lab manual. So you want to take your measurements and compare it to that chart to find out whether your bacteria is susceptible or resistant to the effects of the antibiotic. So we're thinking about whether the bacteria is susceptible or resistant to the effects of the antibiotic treatment that you exposed it to. So let's take a look at how we do this lab. So let's look at the procedure. So what I've got over here, I have my Mueller-Hinton plate. Okay, so I've got my Mueller-Hinton plate. I've got bacterial solution over here and my swab. Let me move that over. So I'm going to go ahead and I'm going to open up my swab. So I have a sterile swab. I'm going to dip it into my bacterial solution. Okay. And then I'm going to take my plate and I open it up and I'm going to literally go from edge to edge. So I'm going to streak the entire plate, and my streaks are very close to one another, and I want to make sure that I cover the entire plate back and forth. Once I've gone one direction, I'm going to turn it about a third of a turn, go in the other direction, make sure I cover the entire plate, and then I'm going to turn it again just to make sure that I cover the entire plate from side to side. Okay. We want to get a nice lawn of growth and make sure that we've covered every single part of this plate from side to side. So once I've done that, I'm going to get rid of my swab. Then I'm going to get my antibiotic, and we have them, our antibiotic discs are in these little kind of dispensers. So you push on the dispenser and the disc should come out like that. We're going to be using some forceps that we've sterilized. I'm going to pick up one of these little discs and put it directly onto my plate, like so. And then I want to gently tap it so that it sticks. Okay, don't push because it'll push right through the agar. So I'm going to gently tap it down, and then I'm going to get a different antibiotic and actually put it on the other side. So I would have two different antibiotics on each side of my plate. Okay. And then obviously we would sterilize our forceps. So once we've got that done, our results are going to look something like this. I know it might be a little bit hard to see, but here's my antibiotic discs. And if you look in the lab manual, you'll see zones of inhibition. I'm going to use my metric ruler to measure across the diameter of the zone of inhibition, and then put it, compare it with my chart in my book. So that's pretty much the antimicrobial susceptibility lab. And that's pretty much it. It's pretty easy. So you have 2 plates per group of 4, and then you'll share information from one group to the other group once you get your results. And that's it. Thanks.